In this example, we're going to compute a power of the z we've been playing with here. And we're going to do it in two ways. We're first going to do it the hard way. Well, it's not hard, it's just there's some bookkeeping. And the hard way uses the binomial theorem. So we're taking that and we're cubing it. And this is like our a is like negative root 3, our b is like negative I, and we're cubing it. And in this case, the binomial theorem tells us that the cube can be represented as a cubed plus 3a squared b, plus 3ab squared plus b cubed. So our a cubed will be negative root 3 squared, and then 3a squared will be 3, or cubed rather, sorry. 3 times negative root 3 squared times b, or b is negative I, plus 3 negative root 3 times negative I squared, and then plus b is negative I cubed. All right, negative root 3 cubed is going to be negative 3 root 3. Negative root 3 squared is going to be 3. Negative I is going to be negative I. 3 times negative I is negative 9i. I squared is going to be negative 1. We have another negative on our negative root 3, so they'll become positive. And we'll get 3 root 3, provided I haven't made a mistake so far. And then negative I cubed, if I square I get negative 1, and I multiply it with another negative I, we get I. So let's see here. I think these guys cancel each other out, and we end up getting negative 8i. All right, great. That wasn't very hard, but it was a little bit tedious with our algebra. Now we're going to use polar form. I don't need to put quotes on here, so we'll do it again, but with polar form. So to understand polar form, we need to know two things. We need to know the modulus of z cubed, and we need to know the angle it makes. So let's start off with the angle. Well, z cubed is z times z times z, and our argument takes products to sums. Now, since we're gonna be plugging this into cosine and sine for our polar form, I don't actually care about the multiples of 2 pi. I just want to use a positive number because negatives confuse me. So we computed 7 pi 6 in the previous videos for the arguments a bunch of times. So we get 21 pi 6, and if we were to put this in I guess we can divide a 3 out actually, so let's do that real quick. And then we'll see if we can make it look a little bit nicer. So 3 goes into 21 7 times and 6 twice. So we have 7 pi halves, which is similar to the angle, what? 4 pi halves is the same as 2 pi, so this is sort of similar to 3 pi halves. I want to put it in this form just so I can compute cosine and sine. So that's our theta. And then our r is going to be the modulus of z cubed. But the modulus of z cubed is the modulus of z and then cubed. And we computed the modulus of z in the first example. And we found that the modulus of z was 2. So that's 2 cubed, and that's an 8. So this is telling us that z cubed is, of course, our r, which is 8. And then cosine of our angle plus I sine of our angle. So that's what? Well, that's going to be 8. Cosine, this is 270 degrees. That's a 0. And then sine of 270 degrees is a negative 1. So we get negative 8i as our computation for z cubed. Now, if you you're probably thinking, or you might be thinking, wow, that was a lot of work to do what we did with just what appears to be a lot less work in the previous example. And that is true. That is completely true. And if I were given this problem, I would probably just cube it using the binomial theorem and then go on with my life. However, if we instead asked, which we're going to do, we're going to be computing very large powers of z later when we talk about things like power series, and we're going to need to be able to manipulate them. So if we instead asked a large power, say z to the 2024, all of a sudden this is very difficult to do with the binomial theorem, right? Because we have to do just a lot of work. However, z to the 2024 is going to be our, before it was 2 cubed, now it's 2 to the 2024. And then before it was cosine of, what was significant about 21 pi 6? Well, it was 3 of our 7 pi 6. And why 3? Well, we had 3 z's. Well, now we have 2024 z's. So 2024 times 7 pi 6 plus I sine 2024 times 7 pi 6. And that would be some number that if we really cared, we could compute. But that was a lot easier in this case to use than the binomial theorem.